3.1 usually starts with something like this, where we have to do some sort of construction of a triangle. So we have tan beta equals 3 over 4, and then it says where beta is an element of 180 degrees to 270 degrees. So it says with the aid of a sketch and without the use of a calculator, calculate this. So 3 marks isn't for answering this guy so much, but a lot of marks are given for the construction. So if we have tan beta over here equals 3 over 4, a reminder that we have SOHCAHTOA. So we have that, or we have SYR, XYR, TIX. So SYRCXRTYX, or shelter your rear because X-rays tan your exterior. Okay, so these are the setup as far as what this means. Because right now we have tan beta, which means we have the Y over the X. Okay, that's very good for us as far as the construction that we're headed towards. And then we have a positive tan over here. Okay, so if we are doing our construction over here, this is our cast diagram where only cos is positive here, all of them are positive here, sine, cos, and tan. Only sine is positive here, and only tan is positive here. So this is telling us tan beta equals 3 over 4, and tan beta is positive. So tan is positive here, and tan is positive there. And then they've given us this restriction over here where beta is an element of 180 degrees to 270 degrees. So we have 0 degrees, we have 90 degrees, we have 180 degrees, we have 270 degrees. Okay, so that means element of 180 to 270, it only fits in this quadrant here, which means we are just dealing in the third quadrant, and that is where we're going to do our construction. So now that we have figured out the values of our y and our x, we figured out which quadrant we're going to construct in, we can go ahead and we can draw it here. So we're going to draw the radius from the origin, then we're going to connect it up to the x-axis. Cool, and then we're dealing with a right angle triangle that is here. So one thing to note is that this x here is 4. So we have 4 this way, but then we have to place it because negative x is to the left and negative y is to the bottom. So they haven't told us this negative and that negative, and that's why they've cancelled out, because a negative 3 over a negative 4 is a positive ultimately. But we have a negative 4 for our x value and then a negative 3 for our y value. If it was on this side, we'd have a positive x. If it was going up this way, we would have a positive y based on our Cartesian plane. But now we have a negative 4 here and a negative 3 based on this triangle. And then what we need in order to just plug anything into sine b, because sine b equals y over r. So it means we need the r, and that is why we're doing this whole construction, is that we then have to go ahead and we have to plug this into Pythag to get our hypotenuse or our radius from the origin, which means we can ignore the negatives when we plug it into Pythag because the negatives are ultimately going to become squared, which means they're going to disappear anyway. So we're going to have 3 squared plus 4 squared equals r squared. And then we can go ahead and we can solve for this. 3 squared is 9 plus 4 squared is 16 equals r squared. And then 9 plus 16 is 25 equals r squared. Square root that, therefore r equals 5. And then our radius is always positive, whether it's going here, there, or in this quadrant 3 where we're at. So we have a positive 5 for our radius. And that means we've set this whole thing up without using a calculator. And then we can just go ahead and we can plug it into here. So our y value, because we're not trying to get the angle of the beta. We don't want that, but we do want what these sides are represented in the form of sine beta. So this is beta over here. And now we just need to take the sides that correspond with this trig function, which means if we put our negative 3, because that is our y, over our r is 5, we will then be done. And that'll be our answer for this guy.